Prosthetics date back to ancient civilizations, with the first known prosthetic device being two toes that were found on a mummy from ancient Egypt. Before this, the earliest known example was the Roman capula leg found in Capua, Italy in 1858 and dated back to 300 BC. Early prosthetic limbs appear in historical literature most prevalently as peg legs and hook hands as those seen in traditional pirate lore, but in fact prosthetic technology left this antiquated model behind a long time ago. In the Dark Ages, prosthetics were used mainly for aesthetic purposes rather than functionality. However, during the Renaissance, prosthetics developed to include metals such as copper, steel, and iron. A knight named Gotz von Berlichingen, who lived around 1500, was recorded to have owned a prosthetic arm made of iron that included hinges for the elbow and fingers so that he could use his arm to fight. Ambrose Paré, considered to be the father of prosthetics, presented his modern amputation procedure to the medical community in 1529, and by 1536 had created prosthetic models that have features still in use today, such as a fixed position and a knee lock. More than a century later, in 1696, Peter Verdouin created below-the-knee prosthetic that did not lock, and this model is used for today's joints prosthetics. Demand for prosthetics increased rapidly during the American Civil War and then again at the start of World War I. In 1868, Gustav Hermann introduced the use of aluminum to make prosthetic limbs lighter and more usable for amputees. This method has recently been improved upon with the creation of titanium osseointegration, which replaces the need for the socket part of prosthetics, which often causes pain and damage to skin. Osseointegration involves implanting a titanium piece into the bone marrow and allowing the implant to merge with the bone. Another titanium extension is attached to the bone implant and protrudes through the patient's tissue as the base for the prosthetic limb. Titanium is specifically used for these implants because of its anti-infectious properties that decrease the probability of amputees becoming infected from their implants.
Titanium was discovered in 1791 by English mineralogist and chemist William Gregor and independently rediscovered in 1795 by the German chemist Martin Heinrich Klaproth. It was successfully isolated to its pure form from a titanium oxide compound formed between 1906 and 1910 by metallurgist Matthew A. Hunter. In 1932, William J. Kroll was the first to produce large quantities of ductile titanium by combining titanium tetrachloride with calcium, but later, in 1938, changed the reducing agent to magnesium metal and is now considered the father of the modern titanium industry. Titanium comprises 0.44% of the Earth's crust and is found in rocks, soil, meteorites, sand, and clay. It is extracted through mining, and some countries with workable titanium mineral deposits include the United States, Australia, Sierra Leone, Ukraine, Norway, and Malaysia. Its most common minerals are rutile and ilmenite. It's reactive toward nitrogen and oxygen at high temperatures, which makes its purification impossible through the common method of reducing the oxide using carbon. Instead, it uses the extraction process designed by Kroll in the 1950s, in which its ores are treated with chlorine to yield titanium tetrachloride, which is then purified and reduced with molten magnesium in an atmosphere of argon to produce a spongy mass of metallic titanium. After residual magnesium and magnesium chloride are removed, it is fused in an electric arc and cast into ingots. Titanium has a melting point of 1,660 degrees Celsius and a boiling point of 3,287 degrees Celsius.
Titanium's largest demands come from the United States, who is also the largest producer. Worldwide, its top producers are U.S., Russia, Japan, China, Britain, France, Germany, and Italy. In 2016, the U.S. consumed $560 million worth of titanium mineral concentrates, mainly used for pigment producers, where it is used in paint, paper, and plastic coloration. In addition to its use in pigmentation of commercial products, it is also used for parts for aircraft and spacecraft, ships, and missiles because of its corrosion-resistant properties. It is also used as deoxidizer in steel. Titanium is commonly used for jewelry because its hypoallergenic properties make it safe for people to wear with metal sensitivities. Titanium's biocompatibility comes from its low electrical conductivity and results in formation of passive oxide layer that resists corrosion. This makes it useful for many biomedical applications in addition to limb prosthetics, including dental implants, pacemaker, bone plates, artificial knee and hip joints, cardiac valve prostheses, and screw for fracture fixation. Titanium remains expensive because of the complicated Kroll process of extraction that requires, but medical community is currently researching alternatives such as metal injection molding in search of a way to make it more accessible to many medical patients who could benefit from its unique property and applications.